Now that we know how to factor quadratics pretty well, we're going to use the same thinking to factor some higher degree polynomials. The degree of a polynomial will tell us how many solutions there are. So if we had something that was a cubic, degree 3, there should be 3 solutions. If it was a 4th degree function, then it would have at least 4, or it would have exactly 4 solutions. 5th degrees should have 5 solutions. So we know already how many roots there are just by knowing the degree. Now, one thing to remember is that not every polynomial will be able to be factored. If it can be factored, we can use some of our similar quadratic techniques. So here we have a polynomial that's cubic, and when I look at the terms, something to notice is that there is a GCF. Our GCF of 2 goes into everything, but there's actually more than just 2. Every single term has an x with it. So I could bring a GCF out as 2x. You always want to look for a GCF first. So if I divided this first term by 2x, I get an x squared left. Minus, if I divide 14x squared divided by 2x, I get a 7x. Plus, and then 24x divided by 2x is going to be a 12. So all we're doing is dividing out that GCF, something we've already talked about, but this time it happens to be a variable. This can continue to factor, so what I would do here is factor the x squared minus 7x plus 12. That x squared factored from x times x, and then our factors of 12 are 3 and 4, 6 and 2. We'll learn that 3 and 4 work if we had a negative 3 and a negative 4, because that combines to give me a negative 7x. So this is in factored form, and there are 3 factors, 1, 2, 3. They're all multiplied together. That's what we talk about when we're doing factors. So if I set each factor equal to 0, using the zero product property, let's just write that off to the side, zero product property. All we're doing is saying that 2x could equal 0, x minus 3 could equal 0, and x minus 4 could equal 0. If I solve those, I'm just going to get 0 here for the first one, 3 for the second, and 4 for the third. That actually tells us quite a bit about the graph. So we'll have another lesson on graphing polynomials, but we do know that it crosses at 0, and then again at 3, and again at 4. Those are our x-intercepts. If I think about multiplicities, every single one of those was a multiplicity of 1, so we're just going to go straight through the axis. So our function would kind of actually look something like this. All right, so number 2, we're thinking about how do we factor something that's in quadratic form. So if I look at this, this is not a quadratic because it's not just an x squared function, but it is something that's considered quadratic-like or in quadratic form. And I want to talk about what that means, because if we had something that was x to the 4th, x squared, and a number, and those are our 3 terms, then I could factor it as x squared times x squared. All right, if it was x to the 6th, I don't even need that parenthesis there, x to the 6th plus x to the 3rd plus a number, this would factor into x cubed times x cubed. So as long as the trinomial has this pattern where the middle term is half the degree, the exponent, as the beginning one, it would be considered quadratic-like. So what we're going to do here is just go ahead and factor this into x squared times x squared. X squared times x squared is x to the fourth, but our factors of 14, that would give us 14, would be something like 7 and 2. We want to get a positive 5x squared. So if we check our factoring right now, I get a 7x squared and a 2x squared. That would work to give us a 5 if we did a positive 7 and a negative 2. So this is our factored form. We do check to see if anything else factors, but x squared minus or plus 7 will not factor, and x squared minus 2 won't factor any further. If I thought about what a difference of squares were, we also discussed difference of squares. Where something like a squared minus b squared. X squared minus 9 would factor, but x squared minus 2 won't. This would have been x plus 3, x minus 3. So neither one of those would continue, but we can use that zero product property. Let's take that and this and find our solution. So x squared plus 7 equals 0, and x squared minus 2 equals 0. We solve it out, I'm going to get x squared equals a negative 7. And when I square root both sides, I do get my plus or minus. That's the square root of a negative 7. That automatically tells me it's an imaginary value. So negative, or plus or minus, I square roots of 7. That's 2 of my solutions. Then we do this other factor to get plus or minus the square root of 2. Square root of 2 doesn't simplify further, so we have this. If you look back at what we started with, we had a 4th degree function, so there should be 4 solutions. Well, we got 4. 1, 2, 3, 4. Because each of those have a plus and a minus, there are 4 solutions. All right, number 3. X to the 5th. That tells me that there should be 5 solutions. But when I look at this, it doesn't look like it's in quadratic form, because this is a 5th power, and that's a cube, and that's not half of 5. So that doesn't make sense. But we always look for a GCF first, and there is a GCF of x in this function. So I'm going to bring out an x, and then I'm left with an x to the 4th minus a 4x squared minus a 45. That is our quadratic-like expression. So it's not a quadratic, but it is quadratic-ish. And I can continue factoring that trinomial into x squared times x squared. That gave me the x to the 4th, and then I need factors of 45. So factors might be 9 and 5. 9 times 5 does give me 45, and I need them to combine to give me a negative 4x squared. So this was a negative 9 and a positive 5. That would work. If you noticed, we just talked about a difference of squares, but that is a difference of 2 squares. So it's not completely factored until I take that into x plus 3 times x minus 3. This x squared plus 5 cannot continue factoring. So it's just going to be left as x squared plus 5. This would be in completely factored form right now. We take each factor and set it equal to 0. So x equals 0, there's really nothing to do there, but x plus 3 equals 0, x minus 3 equals 0, and x squared plus 5 equals 0. We solve each one of these. There's negative 3. This one I can go ahead and circle. And then the last one, x squared plus 5 makes x squared equals negative 5. So x equals plus or minus the square root of negative 5. And there's our imaginary solution, so plus or minus I square roots of 5. And let's just glance back at what we were supposed to have. We have a 5th degree, so there should be 5 solutions. And we've got 1, 2, 3, 4, 5 because of the plus or minus. All right. The last thing we have is factoring by grouping. And this is done when we have 4 terms. So everything we have seen so far had 3 terms, a trinomial. 1, 2, 3. But if there are 4 terms, we can do something called factoring by grouping. So if I look at this cubic function, I'm first going to check for a GCF, and 5x cubed, 40x squared, there's a GCF there, but when I put the 2x in there, there's not a GCF, and there's not a GCF throughout the whole thing. So we don't have a GCF all the way. What we're going to try to do is group this expression. And you'll see if you look this up in other videos, some people use parentheses around this, but I just try to highlight or underline the first group of 2 and the next group of 2. So we're going to look at this pairing first. And in this pairing, 5x cubed and 40x squared, I can factor out a 5x squared. So that would be what is considered our GCF for the first pair of values. It's going to have an x plus 8 left. So all I'm doing is trying to factor out a GCF of the first 2. When I factored out a 5x squared from that first term, I'm left with an x. If I factor a 5x squared out of the second term, I'm left with an 8. That's what we start out with. Then we go to this next pair. So negative 2x and negative 16 has a GCF of negative 2. So negative 2 times x plus 8 again, because if I divide that by negative 2, I get an x. Divide negative 16 by negative 2, get a positive 8. So we have an expression that we didn't change any except for we put it in factored, a little bit of factored form. It's not completely factored. Completely factored would mean that there's only multiplication between the different factors. So here we had multiplication between every single factor, but right now we have subtraction. Something to notice is that both of these terms have an x plus 8. That's important. We needed those to match because what I can do is factor this out as a GCF. If I take an x plus 8 out of this term, I have a 5x squared left. If I take an x plus 8 out of the second group, I have a minus 2 left. This is a factoring by grouping for our function. If I look back at 5x squared minus 2, that's not a difference of squares, so I can't continue factoring this. This is as factored as it would go, and it is in factored form because we just have multiplication between the 2 factors. I'm going to set each factor equal to 0 using our zero product property. So x plus 8 equals 0 and 5x squared minus 2 equals 0. This would just give me x equals negative 8. So that one we've seen, all right, but this has a little bit more work to do. I got to divide by 5, I get 2/5. And then when I square root, that's plus or minus the square root of 2/5. So that's not going to be pretty, but it is a value. It's not imaginary. And we get 1, 2, 3 roots. So we had something that was degree 3, and we did get 3 solutions. Number 5 here, if I look at all of the terms, there's not a GCF between all of them. So we start by grouping the first 2 and the next 2. So this would say 2x cubed and 9x squared. There's no value that is a common factor of 2 and 9, but both of those have x's in common. So I can actually pull out an x squared from both to leave me with a 2x minus 9. Then we look at the next part. So I have a negative and 14x and 6. Well, that's not gonna give me anything besides negative 2, so I get 7x plus 3. I've grouped this out, but the problem with this grouping is that these two things do not match. And we needed them to match for me to factor by grouping. So this comes into an important thing for us to realize, is that this can't be factored by grouping. If I worked it out as best I could pull out a -2 from the next group and an x squared from the first group, but neither one of those is going to end up giving me something that matches. So not everything's going to factor. This is just not factorable. All right, for now we don't have a way to find the solutions of that. All right, we go to the last one here. I'm trying to group these. So I have x squared that I could bring out of the first group to leave me with x minus 4. And then if I look at the last group, -x plus 4, there's no GCF between those. But I can bring out a -1. Because what happens when I bring out a -1 is I'm left with an x, and then 4 divided by -1 is a -4. And nicely, this will match. So x minus 4 and x minus 4, we do have a GCF. So I'm going to bring that out as a GCF from each. So x minus 4 times x squared minus 1. The coefficients became the next factor. Leave my h of x out here. And this actually continues factoring because I noticed that this is going to be a difference of squares, x squared minus 1. So x minus 4 times x plus 1 times x minus 1. Nothing else continues to factor, so this is in completely factored form, and we would get our 3 solutions from here. So x minus 4 equals 0 gives me an x equals 4. X plus 1 equals 0 gives me an x equals -1. And x minus 1 equals 0 will give us an x equals 1. There are 3 solutions. So factoring by grouping will not happen every single time, but if it has 4 terms, we can at least try to see if it will factor. If it doesn't, then it's going to be not factorable, and we don't really have a way to get the solutions at this point.